It's now time for our first plenary conversation. So please welcome Dr. Sue Kay, who will moderate our first plenary called Emerging Technologies for Global Challenges. Dr. Sue Kay is a robotics and AI expert from the University of New South Wales AI Institute. An ATSI Fellow and brilliant speaker, she is an advocate for the responsible development and use of novel technologies in work and life. Please welcome Dr. Sue Kay.
Well, hello and welcome everyone to KATE's 2025 and to our panel on emerging technologies for global challenges. We've a panel of eminent speakers who each bring unique insights into how science, technology and engineering can shape sustainable future across generations. I'd like to invite our panellists to assemble, but just please note there is a handrail, don't come up any other stairs. First off, I would like to welcome Sir Peter Gluckman, President of the International Science Council and one of the world's most distinguished biomedical scientists. He's the founding director of Koitua, the Centre for Informed Future, an independent think tank, and he's also the Emeritus Distinguished Professor at the University of Auckland. From 2009 to 2018, he served as New Zealand's first Chief Science Advisor to the Prime Minister. His pioneering research has shaped global understanding of how early life environments affect lifelong health, and he has been a leading voice on science policy, diplomacy, and society. Sir Peter is a Fellow of the Royal Society of London, the US National Academy of Medicine, and has received New Zealand's highest civilian and scientific honours. So please join me in welcoming Sir Peter Gluckman. So building on that global perspective, our next panellist is a leader who has shaped innovation and technology policy both in Japan and internationally. Dr. Yuko Harayama is Secretary General of the Global Partnership on Artificial Intelligence Tokyo Expert Support Centre. She has held senior leadership roles in Japan's Cabinet Office and at RIKEN, and internationally at the OECD. Dr. Harayama is also a trustee of Yamaguchi University and a board member of Toray Industries. With doctorates in both education and economics from the University of Geneva, she brings a uniquely interdisciplinary perspective to innovation policy. Recognised with the Legion d'Honneur as a Fellow of the International Science Council, she champions a human-centred approach to emerging technologies. So please welcome Dr. Yuko Harayama. And next, I'd like to welcome Chandrakant Patel, who was the Chief Engineer and Senior Fellow at HP and a pioneer of Silicon Valley innovation for more than 40 years. He now offers Chandrakant as a Service, CAS, with the mission to learn, teach, guide, and solve. He has led breakthroughs in computing, storage, and 3D manufacturing, and founded HP's Smart Data Centre program, which transformed how the world manages energy-efficient computing. A thought leader on AI, cyber-physical systems and sustainability, Chandrakant emphasises that technology must save more energy than it consumes. He is also a dedicated educator, teaching for over 2 decades and supporting local workforce development. So please join me in welcoming Chandrakant Patel. And now turning to cutting-edge research and applications, where the next generation of artificial intelligence is being advanced right here in Australia, Dr. Liang Zheng is Associate Professor at the Australian National University and an ARC Future Fellow, as well as a research scientist at Canva. He is internationally recognised for his work in computer vision and generative artificial intelligence, having developed some of the field's most influential datasets and algorithms. Dr. Zheng plays a leading role in global AI research communities, serving in senior positions at top conferences such as CVPR and NeurIPS. His current work explores how AI can not only advance design and creativity, but also help preserve cultural and Indigenous languages. Please join me in welcoming Dr. Liang Zheng. So we are running a little bit behind schedule, but I don't want anyone to worry that you're not going to get morning tea. We have sorted that out. So the panel is still going to run for the 60 minutes that was originally proposed, but that does not mean that you're having to trade in listening to this panel for morning tea. So just to set everyone at ease. Well, first I would like to ask all of our panellists to maybe expand on your background, if that's appropriate, and talk to us about the emerging technology you think is most important to help solve global challenges. So if you don't mind, please, we'll start with you, Peter.
Well, I want to start really from a different point of view. The world is changing faster than ever before. And if we just go back 10 years, 2015, the Sustainable Development Goals, the Sendai Framework for Disaster Risk Reduction, the Paris Accords. Now, to go 10 years later, change at a geostrategic level we wouldn't have thought about, a decline in trust in elites, and everybody in this room is part of the elite of science and technology is very different. We've seen a focus more on nationalism and immediate transactionalism rather than on long-term thinking. We've experienced COVID, and yet the world hasn't responded well to how it will prepare about future pandemics. So I think from the point of view of the International Science Council, which is the largest organisation, and sadly, CATES and ATSE are not yet members of the International Science Council, and they should be, its focus is on bringing the social and natural sciences and technological sciences together, because the challenges of the future, the engineers and scientists will make great progress with the technological and scientific aspects, but the reaction from society to those developments may not be positive, unless we think a lot more in partnership between technological development and social license and social development. The concept of social license, which it was developed in the by Vannevar Bush and others in the 50s, 60s and 70s, no longer applies in a world which is very different. And I think Yuko and I would both agree, the issue is not the genius that you will bring to develop new devices, new solutions. It will be whether it will be equitable, whether it will promote greater inequality or more equity, and whether the society will accept your developments or resist them. We've seen just post-COVID resistance to vaccination, resistance to life sciences technology. We're seeing that we have lost the social license for this very rapid development, which is now going too fast for society to cope with it at any level. And artificial intelligence and quantum are just going to put fire on the fuel of speed. And we need collectively, and I'm a great believer in moving fast to solve the solutions that the world has. But if we don't bring society with us, we may get an reaction even stronger than that we're seeing around the world at the present time.
So we can't solve global challenges with technology if we don't have social license.
And that social license is not just at the individual level, it's at the multilateral level. We lost the game when we didn't regulate the internet globally at the beginning. And now what we've done is we've created a situation where a few large companies are ignoring national sovereignty, and what we have is an inability at any level. I've chaired for Cabinet in New Zealand. I've got to show off for a minute. New Zealand joined Horizon Europe several years ago. We at least could beat Australia in rugby, and in doing that. But I think that if we don't think through the issues of the loss of national sovereignty over technological advances and how we create a multilateral structure that can deal with these issues, the issues are going to get larger and larger and larger.
Yeah, thank you. Yuko.
I'll be following Peter's perspective because we are sharing many, many values. 50 years from now, for sure, we can say that we have many, many disruptive technologies for sure. But compared to the past 50 years, it's much more accelerated. And the differences will be that today, we took a long time to consolidate social system and, as we say, democracy or going global or network society. It took many years to be into place, and we thought it was taken for granted till last year, something like that. But today, we have to think about these consolidated system. It's not for sure that in the coming years, in 50, much less than 50, in 10 years, we have to work together in the way to keep these social institutions as a core infrastructure. And some of them are enhanced by technology, but some of them are disrupted by forthcoming technology. Even we see some flavor coming with the AI implementation. So be careful, and to address all these issues, it's not only investing in technology. We have to invest in technology. We have to enhance our capacity in terms, anyway, many engineers in this room, their kind of spirit is making better world. But it's not enough to have this power. And we have to work together in the way that we have to think about the sense of community, sense of collaboration, not just saying it is a good word, to put into practice beyond the national border before the competitions. It's nice to have a competition, but just to make sure that we will sharing the same value. And also, at the same time, we will be enhancing our capacity into different generation to be able to use smartly all the new technology. But at the same time, we have to enhance what we may call the human agency. Otherwise, you'll be dependent on technology and you are not mastering. You will be embedded by something that we don't know yet. We didn't have any experience like this today. So we have to be ready, and for that, we need to empower people, next generation. And not only in terms of technology, but in human dignity.
Thank you, Yuko. Chandrakant.
Yeah, you had a two-part question, one about adding about myself, and then the technologies that I see are exciting. So rather than talk about myself, in keeping with what Michaela talked about and Catherine talked about on preparing the next generation, I will look at my own journey in Silicon Valley, and what I call for the youngsters and the Elevate scholars here is to become T-shaped, T as in tango, where you have depth in physical sciences, because we are entering the cyber-physical age. Depth in physical sciences and breadth in cyber sciences, but not just in cyber sciences, in economics, art, culture, traditional ecological engineering. I would hope that our scholars will take a class from Professor Sid Domick and learn about traditional ecological engineering. The reason I suggest that we become systemic T-shaped contributors stems from the challenges we face in the next 50 years. If I were to use a framework steeped in supply side and demand side being the resources that meet the needs of society, basic needs of society, and the various disturbances between supply and demand, aging demography on the demand side, lack of subject matter experts on the supply side, the resource constraints, negative externality-driven burden that we face, urban wildfire, on and on and on. These disturbances between supply and demand must be addressed with technological solution. The solutions that we create must matter to society in light of these global grand challenges. And like Catherine said, we are leaving a world much more worse shape for the next generation. So how will the next generation undertake the challenge? And therein lies the opportunity to address technology. I believe that the next set of technological solutions are cyber-physical. They're not just cyber. We keep talking about IT. The conversation must shift from IT stack, which is user to database, to cyber-physical stack. Fundamental domain knowledge in physical sciences, first principles domain knowledge in physical sciences, thinking about the actuators and sensors we would use to build solutions, then walking up to computation, communication, AI. So in other words, a stack of technologies that will define the cyber-physical solution. That's what we need to prepare. And what are these cyber-physical solutions? These could be like robotic surgery. So consider one trend. My son is a cardiothoracic surgeon. There are only 4,000 cardiothoracic surgeons in the United States, in a country of 333 million. It's a 22-year journey. Kids can make more money being an influencer on YouTube. Why would you go into that field? So how do we scale these cardiothoracic surgeons? The way we scale them is they will do remote surgery, they will do robotic surgery, and these remote surgeries, robotic surgeries are cyber-physical. They're not one technology. So to say that I'm excited about AI, the context is cyber-physical system. I am excited about AI as physical AI that matters to society and leads to cyber-physical solutions for the next 50 years that address those challenges. And those are not just engineering. It also starts with traditional ecological engineering. We must learn from our ancestors and bring those solutions into the cyber-physical solutions that we will build. So it's a stack of technologies I'm interested in, and specifically AI that matters to society.
Thank you. Liang.
All right. Hi, everyone. My name is Liang. I came to Australia 9 years ago as a postdoc, where I spent 2 years at UTS before I moved to Canberra. I've been teaching in ANU for teaching and research at ANU for 7 years. So I think the challenge for the next 50 years is that how can we remain humane? So at the wave of AI. So companies have invested billions of dollars developing very capable language models that focuses on big languages, English, Chinese, big languages. But so how about our small communities? I've been working with linguists at ANU, where they study Aboriginal languages. Some of the languages are disappearing, and the language called Wardaman that we've been studying is now spoken by only 2 people, elderly people, in the Canberra region. So how, if we are spreading these language models to everyone, how can we preserve our own culture that matters to our future generation? It's a big challenge. On the other hand, I've been teaching at ANU for 7 years, and I found that student emails to me have been improving a lot since last year. Their emails are super nice, super machine, and I wasn't able to see the person behind it. So if this continues, in future, students, they become the same. They give the same language, even English, same tones, same style. How can we make ourselves humane? And also, when we teach programming like Python, Java to students at universities, what we found was that students learn much slower than before because they can finish their assignments using GPT instead of writing the programs themselves. So they're not learning. So how to address these challenges for our future generation? How can we let students really learn the language? How can we allow people to still have access to our disappearing languages? I think that's a significant thing that we need to think about.
So when considering solving global challenges, we also need to consider, are we preparing people in the future? Thank you.
Exactly.
So We are having a discussion up here at the moment, but we will be taking questions soon. So if you want to scan the QR code that is on everybody's table, then that will direct you to Slido where you can ask questions of the panel, and we'll try and get through as many of those as we can after we've finished this discussion. Well, next I would like to ask our panellists, let's put to one side, hopefully if we could solve the social license issues, what would you think the world might look like, and what would the technology landscape be in 50 years' time? What problems might we already have solved if we can solve this issue around social license? Oh, sorry, can you pass?
I don't think it's possible really to answer that question in a sensible way, because the technology, it depends who controls the technologies. Are we dealing with governments and the multilateral system working, or are we dealing with companies and individuals controlling the core platform technologies? If you look back, when I went to school, you had to read 2 books, 1984 and Brave New World. Both of them remain possibilities into the future. I've got no doubt that technologies will address many of the problems we face now. I'm a life scientist, so I'm thinking obviously about a lot of the challenges in neuroscience. One of the biggest challenges is understanding how we get beyond biases. How do we actually deal with the emotional stresses of a rapidly changing world? We can't live with a society which has 25% of young people mentally distressed because they're not coping in this modern world. So there's lots of issues here where technologies and ways of investigation will change the way in which we understand the way the brain works. They'll lead to challenges. We may see neuroenhancement, which actually leads to greater inequalities between people. We're seeing for the first time, I think last year, more scientific papers were published from the global south than from the Western countries. What does that mean in the future when science, which is a universal language, has a different cultural and historical context in which it operates? So it gets difficult. Yes, of course we'll solve the battery problem or the energy storage problem or the capacities to distribute technologies to deal with cardiac surgery or whatever. I think they're all straightforward issues, but I think the issue that Yuko and I have both raised of how our society will operate, can democracy survive AI? Can it survive targeted mis- and disinformation and individualised manipulation? What does democracy mean in that context? These are real questions. They're not superficial questions. They're questions my centre's dealing with every day. This is where natural science, engineering science, and social sciences need to work now together and work with political science to try and find solutions, because we need the technological solutions to the immediate global commons issues, climate change, pandemic risk, etc., urbanisation issues. But it won't work unless we also think about these broader dimensions.
Thank you. Yuko?
So I'm following what you say about your students, because your concern about your students. My concern is about my grandchildren, because from now, 50 years from now, my grandchildren, they will have 50, 60 years old. It's up to them to really lead the society. And now they are playing with that, and they're really embedded by cyber world. And it's not our experiences. And it's a new context. And how to keep developing human skills will be the key challenges for today, not for the coming years. Because if we are losing this sense of human being, as you mentioned, being able to use all the AI and all the technology, because you have your own skills, your way of visualizing the world, thinking about what you're doing and what the value system, if from the beginning you were embedded by this, surrounded by all the flow of information, and average thinking will be in place, not using your own mindset. And even today in primary level schools, they are using much more digital tools and less writing, less reading, less interacting human to human. So this part will be reduced, and we have to ask ourselves, it's a right way to bring next generation as human leaders. So how to compensate to be able to use all this surrounding technology, and in the coming 50 years, much more technology, much more sophisticated one, as you can imagine easily in Silicon Valley. So how to deal with that? That's a big challenge for me.
So I'm going to, I think Peter mentioned that some of the challenges that I'm talking about will get solved in due course. I'm going to a little bit disagree on that. After all, this is a panel. I think that when you talk about climate change, I completely concur with you, urban wildfire. But we have been motivating this problem. For 10 years, we keep talking about the sky is falling. I don't see the action taking place. The reason the action is not taking place is we are not approaching sustainability with first principles. It's become a virtue signaling game. So I contend that the opportunity we have is to apply first principles. 0.7 millimeter pencil on a paper is where I start my problems. And then ultimately I do it with first principles, and then I go to higher order analysis and simulation. So teach people to start with first principles to address these challenges. And so let's take an example in sustainability. If we are going to move the needle in sustainability with all the talk about AI and all the joules we are burning writing letters and writing papers that look alike, it's time to take that AI and channel it where it makes a difference. So the other day I was under the Golden Gate Bridge in San Francisco. I look at it and I ask myself, if I use AI today, will I use less lifetime energy to build that bridge? And will I be able to build that bridge in the same time? So in other words, the joules of available energy used in extraction, manufacturing, use, reclamation, cradle to cradle, 1935, versus the use of AI today, will I be able to build that same bridge for less available energy? And available energy from second law of thermodynamics, the quality of energy. So if I could, and I do it at scale, then I will make a difference. But I don't see any proof points. I see a lot of talk about AI will be good, but where is the paper that shows, here's how I'll build the Golden Gate Bridge, it'll be done in due time, it will use less energy. Secondly, AI itself needs a metric. And I have a metric at home. It's net positive impact. So when my kids do frivolous activity and move terabytes of pictures to the cloud, I ask them, how many joules of available energy did you destroy for that frivolous activity? So I ask myself, if I were to use AI, the solution I build with AI must save more energy on the numerator than the energy utilized, lifetime energy utilized by the solution inclusive of AI. So I think those kinds of metrics, enforcing those metrics to build lots of solutions at scale will make a difference. But I don't see that happening. And I think part of it is we are not pushing back on how sustainability is being approached.
Yeah, thank you.
Okay. Right. So I tend to think AI as the third industry revolution for us human beings. So in order to answer Sue's question about what the world would look like in 50 years, I think things will be super exciting and hard to imagine. But I want to share one of my opinion, what I don't want the world to look like. So if we think about the first industry revolution, that started in the UK. So that started a couple of hundred years ago, right? So, and then UK had, strong advantage over the rest of the world. And then what happened was wars, colonization, these kind of things over the next 100 years. So then if we put in the analogy to the third industry revolution that we are experiencing now, so what I don't want it to look like is that if this thing started from those countries that have very strong AI industry and expertise, then what about small countries? What about minorities in countries? We don't want this to be a new kind of economic war, or no matter whatever war happening in 50 years later, where countries that do not have access to those AI technologies would be, put in a disadvantageous position. So I think it is important that we, when we do this revolution, which is great for the human being, we need to let our generations know that this thing, we need to democratize it. We need to let people all over the world have access to these technologies, even people that do not speak English, do not speak French, they speak small languages. How can they benefit from these things? I think this is what we need to do to avoid what happened in the past in human history.
Thanks, Liang. Well, we have got quite a few questions coming in from the audience, so we might get started on those. And just everyone remember that you can upvote for the questions that you like, so please give us some guidance if there are some questions that you really would like to hear answered. Please vote for them. And this first one, I think, Peter, you might like to tackle first. And this is, how much would a 17-year-old apprentice tradie, a dental assistant, or a fitter and turner relate to this panel discussion? How can we bring them along on this journey?
Well, I think that's the giant question for now, which I think all of us in different ways have been looking at. How do we actually think about how we educate, and I don't necessarily mean in a formal sense, but including in the formal sense, people who are going to live in a world which is moving so quickly. There's a large section of educational science literature about the industrial revolutions that shows that after every major technological leap, there's a period of pain until education and social systems catch up and can exploit that technological change. And it usually, in historical terms, has taken about a generation. But now the technological changes are coming at a pace that neither the education or the social or the political system can cope with. And so we have a problem that's fundamental. It goes down to primary school education. How do we actually train people to live in a world where there's a new dimension, the digital dimension, and the virtual dimension. There used to be one, the spiritual dimension of the past when religion was strong. Now we have another virtual dimension that has emerged. We're going to have to there's a need for fundamental rethinking, and sadly education is the hardest bit of a social system actually to change for a whole host of reasons. And so I think that science needs to be more transparent, but in fact it's not. Let me use a simple, silly example. Pokemon Go. Overnight, out of nowhere, came a new game, innocently produced by the gaming company involved, took over the world by storm, and rapidly undermined a fundamental human value of sacred space. Suddenly spaces like mausoleums, private homes, not of the individual playing the game, of churches and so forth, became places of entertainment. And so that there can be innocent overspill. And so getting back to Chandra's point of before, there's only been one example I can think of where the scientists paused to think about the economic, about the social and political, two examples, social and political examples, implications of technology. You might argue Niels Bohr and Einstein did it in thinking about nuclear, but it had no great impact. But we did see it with the similar conference when molecular biology first appeared. The scientists of the world entered into a voluntary stopped till they worked out how to manage biological risk. And so there was an embargo on progressing for a year or so while the similar process worked through. We didn't see this around AI because it's largely driven from the private sector rather than from the public sector. And so we have some fundamental issues here. I can't answer the question, and I'm avoiding answering the question because I think it's a fundamentally impossible question at this moment to answer, because we do not have the discourse and the dialogue. The Secretary General's trying to do it through the UN. The OECD's tried to do it, the European Union's tried to do it, the science community's tried to do it, but there's not a collective will at the level to think about how we get a global view of how to manage these rapidly moving technologies.
Well, yeah, the next question I'd like to direct to Yuko, and it links to what you've just said, Peter, and that is, what are the 3 most important things government can do to support the science and research ecosystem to prepare for the next 50 years of technological change?
Big question. And the science technology innovation system, ecosystem we have in place today has been constructed through years and consolidated. But today, we have to address many new challenges coming in, not only technologically from the nature, but from the people's interaction, policy, geopolitics, many things. And that means that system in place is any more perfect. We have to be adaptive, and also in the way that there are no unique model, neither US, neither European, neither Japanese, any. But we have to keep in mind that we have to really be able to react to the new environments, and it's happened so many things so quickly. So we do not have enough time to really, make sure that it's working quite well. So it's a challenge for the governments, and the traditional way of identifying, for 5 years planning for new technology to be invested, it's anymore the case. So how we can change the way of thinking will be what we did in Japan 10 years ago. Think about the future society and how we can go in the better society and what could be the challenge for technology, but at the same time thinking about social system and all institutions. But by saying that it's very theoretical, it's not so practical. So the way we will do could be not just saying my model is the best one, but to be honest and to be able to check what we are doing. Sorry. At the same time, we have to allow the government to make some kind of policy experimentations in small scale, and then checking if it's work or not, and this in a collaborative way, not just nationally, but internationally. So experience sharing will be much more valuable today than 10, 20 years ago. So my motto will be learning by experimenting and sharing.
So actually that goes some way to answering another one of the questions here, which were around some of the opportunities and solutions for global collaboration and partnership considering current geopolitical conflicts. The way that you've framed it, it sounds like there is a lot of opportunity in the policy space for governments to be working together.
Just additionally, few words. Because of the so many crises and the conflicts around the globe today, it's difficult to have collaboration in a political formal way. That's why we need to explore different channels, One candidate will be community of engineers, community of scientists, to make sure that we are just not isolated, but just keeping your spirit of community to work together, even there are many barriers to make collaboration. But we have to keep this.
I think the international science community, it's the only international language that really exists, if you think about it, is increasingly reorientating to take this role on. And we're seeing track 2 diplomacy, the level of, at the informal level, and we saw that in the first Cold War, where we saw the Villach Conference that led to the IPCC, we saw the International Geophysical Year, which led to the Antarctic Treaty, we saw the academies of Soviet Union and United States come together to form IASA with other countries. We saw that science working informally could actually get beyond geostrategic boundaries. We're seeing that again now. Just the other day, I had scientists from 2 sides of the Ukrainian war in the same discussion. There's a lot more informal discussion going on at that level. It was valuable in the first Cold War. It will remain valuable in this very fractured geostrategic situation at the moment. It may be the only way it can work, because the politics in this world, when it's too transparent at the political level, actually put people into very, very polarised positions.
Although I won't say that if we look at AI, the research agenda has been hijacked. So, I'm not sure we're in quite the same space where, in the same way the oil industry wasn't able to, completely overwhelm the voice of climate scientists, for example. But that's not a question. I do have a question for Chandrakant, and that is, how will we meet the energy needs and carbon impact of AI and supercomputing, and how do we address sometimes competing needs and pressures?
That's a brilliant question. I think as you look at these data centers, first of all, we need indigenous data centers in Australia. Why do you have, going back to what you were saying, why do you have to rely on warehouse scale, over-provision, high-energy data centers overseas? And so if you were to think about indigenous network of data centers and apply first principles, then the way to think about computing from a Joule's perspective, and people call me Jules Patel, because everything has to go down to, I value things in joules. So use available energy in joules as the currency, and I have a principle. On the supply side, when we build these computing elements that make up the infrastructure, look at the lifetime available joules used, extraction, manufacturing across, minimize that, number one. Number two, for this AI infrastructure, local sources of available energy. Today what happens is you build a data center, get a great negotiated pricing for electricity. The company that negotiates the price wins. The consumer pays more, because after all, somebody's got to subsidize it. So I say that if you're building a data center, get on a treadmill and generate your own electricity. So since sitting on the treadmill ain't gonna work, you say, all right, what are the sources of available energy? Look at the available energy and place the data center accordingly. Wind, sun, variety, and not just, also non-renewable. There is a place for natural gas and so on. Then available energy in waste streams. We have tremendous amount of available energy in waste streams. So build the computing infrastructure on available energy on waste streams. 1 joule at 500 degrees Celsius coming out of a chimney in a power plant, in a factory, has 0.6 joules available, which is being wasted. Similarly, build data center at dairy farms. 2,000 dairy cows, each producing 55 kilograms of manure, can power a 1 megawatt data center. Anaerobic digestion of manure to methane, and then methane to electricity. And by the way, the heat from the IT equipment is perfect for anaerobic digestion, so dump it into the digester. The waste heat from the generator is perfect, it's high grade for absorption refrigeration cycle. I call IT and manure have a symbiotic relationship. So use these kinds of principles to build your own power grid made of available sources and waste stream. Use traditional ecological engineering to build the supply side for the data center, for the compute infrastructure. And on the demand side, instead of saying you have infinite amount of electricity, you say, here is the bucket of joules I'm giving you. from the manure, from the wind. Now run your operation. If I were to give you a bucket of joules, how will you run your operation? So if Peter's workload comes in, and it's not important, I'm going to wait for sun to come out. Yoko's workload is very critical. I'll burn natural gas to run it. So need-based provisioning based on the pool of supply-side resources. These kinds of fundamental-based frameworks are not being used. And within the data center, use sensors and automated control, multi-input, multi-output control, using AI to provision the resources based on the need. No more, no less. Give people when they want, no more, no less. These kinds of first principles need to be used to make for an efficient AI infrastructure.
Thanks, Chandrakant. Well, the next question actually is one, Liang, you can answer, but I will warn you there is a correct answer to this, and if you're giving the wrong answer, you might tell by how agitated I become. No pressure. So, does Australia need to build sovereign AI capability? Example, data centres and large model development, or do we point to the US and APAC for this?
Great question. So I want to point something that's relevant, but it's not super, closely aligned. So before the US Civil War, that was the first industry revolution happened. And the southern states of the US, they grew cotton because that's the fuel for, that's the important thing for UK and for Europe. And that's what happened at the time. And now what happened is that now US is building ChatGPT, which needs a huge amount of data, annotation, and that comes from countries where human salary is lower, and people labor basically is much more and lower in price. So that's what happened now. So for Australia, it doesn't matter, regardless of Australia or any other country, if you want to develop sovereign AI, then we'll need resources in data annotation, in high quality reasoning, mathematics data, design data, etc. So how can we get them? How can we build partnerships with other countries without exploiting them, but building really meaningful partnership? We help people not just benefit ourselves, but benefit other countries as well. So for sovereign AI per se, I think I'm a strong advocate for that. I think Australia must and has to do that in order to keep competitive. So on the other side, we need to really keep in mind how we engage with other countries and data providers to make sure that people have been treated fairly and equally.
Yeah. Yes.
Yeah. So I think I completely agree. Now you look at why sovereign AI. So hitherto, ChatGPT has been built on 30 trillion tokens of text, and someday, humanly possible, 300 trillion. We wrote things and it was scraped and it's gone. But the data that is produced in power, water, waste, transport, I was talking with the brilliant Tanya yesterday from Oregon, all the work they do, the domain knowledge they have, your private data should be monetized. Would you turn over data in life sciences, in healthcare, to somebody else to create a ChatGPT type tool? So I think the opportunity now is not the general ChatGPT, but domain-specific generative AI. So domain, life sciences domain, power, water, health, and that domain knowledge resides here. The data resides here. Use that data. No need to put it out. Build our own. It is a time to drive a truck through this business. And if we don't use that data to build our own tools, like in Australia, based on each of those sectors, then it's an opportunity lost. And in order to build on that data, local data centers are needed. But they don't have to be behemoth. I just articulated the first principles of designing data center. They could be small, modular, distributed data centers. They could be located in factories. They could be located in life sciences laboratories. And that's how we ought to move forward on that.
Thanks, Chandrakant. Peter would like to add.
The related component, and it's been partially addressed, why we need sovereign AI is the issue of data sovereignty. Now, the concept has largely come from Indigenous peoples worrying about how their data will be used. But every country has a lot of data on, not just on their people, but on their environment, on their economy and so forth, which is of enormous importance to them in a sovereign sense. And if they do not set up their data infrastructure in a way to be able to use that data, then whether it's the public sector or the private sector, they cannot take advantage. And that leads to the technological challenge, which I think is on the AI and data community. How do we move to a situation where the ownership of the data, wherever it's used, is protected and the rights around that data are protected? There's a fundamental issue here which we may have lost the early battles over it, but I think the concept of sovereignty, and I think in New Zealand where I come from, the issue of, for Maori people, of data, Indigenous data sovereignty is a huge issue, which is actually confounding how we use public data in the social sector and so forth. We need to solve these problems, not just at one level, but it's critical to the whole concept of AI data sovereignty, I think.
Yeah. Okay, well, thank goodness everybody answered the question correctly. We are starting to get to the end of question time. So if there are any questions currently on the Slido list that you really want to hear the answer to, then please vote for them now. So I'll go to the next most popular question. Someone is asking to hear more from the panel about how to ensure the social license will be available for emerging technologies. So Yuko, do you have a perspective on this?
I didn't clearly capture the question. Could you just...
Someone wanted to know more from the panel about how we can ensure that we get social license.
Today's discussion lies on the table many aspects of the challenge for technology. But commonly, we have the sharing the ideas that we have to have a serving society and serving human and the next generation for that. And this is not just political discourse, but putting into place the practice is key. Because we see every day new version of ChatGPT and other coming in. And it's supportive and also at the same time disruptive what we have achieved by the past. So we have to be adapting and also sharing the ideas that it's not only in your field, in your countries, but it go beyond the border. So the question of sovereignty, again, is not limited to the political definition of sovereignty, but we are thinking about the respect of existing knowledge and also respect of others. So this is the basis for that. But how we can put into practice, it's another question. And also we have to think together, not isolated, but space like today, lots of things that we can take home in the way that in you individually, we can think about and take action individually. So I'm believing that policy sphere is really important to take social actions, but that at the same time, more than ever, individual action is needed in a collaborative way and thinking about not only for you, but for your family, for the society.
Thanks, Yuko. Is anyone else on the panel like to... Oh, yeah, Peter?
What is social license? Social license is an awkward term. It was written, the term was developed in the 60s and 70s and 80s as a rather patronising way of the industrial and scientific community expecting that they would allow, that society would allow it to do what it wanted to do. But social license now is about a relationship. And a relationship is a two-way thing. Am I trustworthy? Do you perceive me as trustworthy? Do I perceive you as trustworthy. It's a relationship. And so science and technology need to rebuild their relationship, which is under threat due to populism, due to relativism, postmodernism, whatever language you want to use. Lots of reasons why trust in elites in science and technology is seen as elites has declined. Populism has a lot to do with it, and populism has a lot of origin, sadly, in things like the global financial crisis, COVID, etc., etc. We need to think of new ways to doing it. So in fact, the number one project for the next 2 years of the International Science Council is actually how do we readdress and create a new partnership, which means probably that the old means of science and technology communication are obsolete, and we need to think of new ways of doing it which are true partnerships. But it's a complex conversation because it's also one affected by the fact that science, the concept of social license was developed when science was almost entirely a global north-western phenomenon. Science and technology are now a truly global phenomenon. That's why we have 31 countries in the room. And therefore, we need to think differently about it.
Did you want to add anything?
No.
Okay, good. Because we have time probably just for one more question, and one has rocketed up the charts from the votes, and that is, I think, Liang, you might like to start on this. How do students try and distance themselves from AI use in their studies when it has become so prevalent?
Well, I think I think students find AI super useful and super fast in helping them complete their assignments. So I think some universities have policies which forbid students from using AI in when doing their studies. In Australia, I haven't heard such policies yet. So and I don't think such policies are useful. We need to teach students how to responsibly use AI when completing their assignments. And I think this, as Peter just said, is a leap. Now things are moving too fast, and how we respond to these things are sort of very challenging. So I think we need to have this education from when people are very young, like from their primary school, probably. So telling them that you should really express your own opinion, write your own language, instead of using AI. You can use AI to help you do some refinement, but things should primarily come from yourself. And this has to stem in people's minds when they are very young. So I think when people are more prepared for this AI wave revolution, I think in 50 years we'll have a new generation which are prepared, much more prepared to be humane, and at the same time using AI to accelerate their work and to build innovation. So I'm very optimistic about that.
All right, thanks, Liang. That leads us into our finisher. So can each of you on the panel, please, in 30 seconds, tell us if you had one piece of advice for a 20-year-old student listening today, what would it be? In any order. Do you want to pass it down to Peter and he can think about it?
So I've got it. My advice is exactly learn the fundamentals, first principles. Don't leave the pencil and paper behind. Don't be distracted by the trappings of the internet. There is no need of a laptop in an elementary school. There is no need to use AI in elementary school. Learn metalworking, woodworking, hands-on physical skills, because the world is cyber-physical. It's not just cyber. So this AI is nothing but a red herring when it comes to everybody getting excited that I need to. It's quite easy to use. So if you were a mechanic with first principles and you needed to build a system that we needed to write software for, AI has democratized it. So if I were to do, say, time to frequency domain analysis, fast Fourier transform, now I can go to a generative AI tool and get the code in Python. So you should be happy that you need the first principles, you are hands-on, and now AI has made software which is democratized, easy for you, and you could be cyber-physical. So stick to the fundamentals, learn the physical principles, use the paper and pencil. That's the advice I gave to my son. He said, anybody can be a mouse jockey, learn metalworking, woodworking. And so when he was a surgeon, he would go on to build tools that could be used in surgery.
Oh, wow. Thank you.
Me. I will advise, or just talking to my student, I would say make value of your own real-world experiences.
I would say, using the T-shaped analogy that Chandra used before, don't learn just one narrow discipline. Learn humanities, social sciences, technological sciences, get a broad base at whatever level, and remember, you are a human being living in a society.
My suggestion is that in your email, I think it's important that you reflect yourself, your own voice. Like people can see a real person behind your email. I think that's super important.
Right, well that wraps up our panel for today. Please join with me for thanking all of our panellists, Sir Peter Gluckman, Yuko Harayama, Chandrakant Patel, and Liang Zheng. Thank you. And remember, it is now time for morning tea, so you are welcome to exit the room, but please remember that there are a whole bunch of, oh, please don't leave because Michaela's up here, and there must be some more announcements. But I was just going to say, don't miss out on seeing some of the panels that are set up, the demonstrations and presentations there, and yes, I hope that you enjoy the rest of the conference. And I'll pass over to Michaela.
Thank you so much, panel. What a fascinating conversation, and I wish we had a whole week to discuss that topic. And thank you also from the First Nations community for allowing us to be seen in a technological science and engineering conversation. It's very rare, so thank you. There is another announcement. So this room is actually going to be juged. So we need you to take all of your things with you, please, and the room will reopen and the panels will restart at 11:30. Until then, we invite you to go and enjoy morning tea and have some great conversations around the yarn that you've just heard. Thanks so much.